Hey everybody, I'm Ryan Strout from PC Perspective. We are here at CES 2017 and wanted to talk to you about one of the things AMD has revealed today, and that is a little bit more background and information on the Vega GPU architecture. This is their next generation GPU architecture coming out sometime later in 2016. They're not being super specific. You're guessing probably something in the summer timeframe. When AMD had a handful of media and analysts out to Sonoma, California in December, they talked about some of the reasons for the decisions they made on the architecture and a little bit about the architecture itself. They did not go into details on performance, expected comparisons, pricing, product availability, anything like that. They just gave some interesting overviews on specific changes to the technology. And one of the things they talked about that they were specific on was memory architecture. And the reason they say they are spending so much time on the memory architecture is because the data sets and the information kind of being built or computed on GPUs has drastically changed, right? They talk about how conventional architectures aren't scaling on a memory side compared to the compute capability of these same architecture. Right? If you look at game installs, they use a graph where they show the Deus Ex games that came out in 2000 all the way up through 2016, and they talk about, game sizes installing up to 70, 80 gigabytes worth of data. If you look at professional graphics data sets, things like movies, right? And you see these almost purely linear increases in usage for like the Lord of the Rings movie through The Hobbit, through the BFG and that type of stuff. And then obviously you get into compute workloads for enterprise and you're talking about petabytes of data necessary for it. And while gigaflops for GPUs have increased drastically, the actual capacity of it hasn't increased that much. Now we say that, but the GPU memory size has actually been increasing faster than the CPU, kind of the platform memory size, right? So they're actually kind of converging at some point. We have 8 gigabyte graphics cards fairly normally now, and we've got 12 gigabytes if you look at like the Titan X Pascal. And this is coming from a company that limited the Fury X to 4 gigabytes because of its implementation of HBM. So it's clearly a statement on the way the way the industry has kind of been moving, right? So by introducing what they call the world's most flexible memory architecture on Vega, they actually are doing a couple things. One is they've created a new high bandwidth cache controller, and then they have built something called high bandwidth cache. But here's the secret: a high bandwidth cache is actually just memory that you're used to seeing, right? They're renaming what people have called GPU memory or frame buffer into something called high bandwidth cache. Now for Vega 10, the first GPU that will come out in the flagship GPU, this is HBM2. HBM2 is the next version of HBM. It has 2x the bandwidth per pin. You have 8x the capacity per stack, which basically means they're no longer limited on memory capacity compared to other memory technologies. This is a big deal for them. So I would fully expect Vega to ship with 8 or 12 or 16 gigs of memory on the GPU, on the package itself. Implementation will still be as it was on Fiji and the Fury and Fury X products, but now they're calling it high bandwidth cache. And the reason they call it high bandwidth cache is because they have built a controller that is now has the capability to actually address up to 512 terabytes of a virtual address space. And then they can actually address other memory, other storage locations, and kind of communicate with it. So you can kind of think of the high bandwidth cache, the HBM memory, as kind of an active working data set, or if you want to get into cache levels discussions, right, it's just a different layer of caches as they go on. Now, it's interesting in some of the diagrams that AMD's shown, they show the high bandwidth controller on package. Maybe it's probably going to be on chip, communicating with the high bandwidth cache, the HBM memory, and then it will also communicate off chip with things like NVRAM, non-volatile memory, aka flash. It will communicate to system memory, system DRAM. They even mentioned like network storage. Now, obviously, network storage is not useful for gaming because it's going to be incredibly high latency compared to what you're used to on any current graphics cards. But it's interesting from an enterprise standpoint in terms of just having the GPU be able to address network storage in that same 512 terabyte address space as local memory. They gave a little bit more detail on the controller. It's adaptive. It is fine-grained, so the ability to like move individual texels of a texture from something like an NVRAM flash storage on the graphics card to the high bandwidth cache as opposed to the whole thing helps solve the problems of graphics or of games needing to allocate a ton of memory for a particular scene or level, but only actually utilizing or touching like half of it or so, which is another data point they showed. They showed Witcher 3 in Ultra 4K and Fallout 4 in Ultra 4K, allocating upwards of 8 gigabytes of memory, but actually only ever utilizing 4 gigabytes of it. Just some of the inefficiencies of modern GPU architectures. So the memory controller is definitely the most important thing that they've talked about thus far. It's really interesting. We don't know the implementations. I think it makes sense if you look what the Radeon SSG product line was and how it, they promised to bring SSDs onto a professional level, not consumer, a professional level video card. But at that point, it was very rough implementation. They were probably just prototyping things out. This is going to be, I think, where we see it integrated more interestingly and effectively here, right? Imagine the GPU that has by 16 lanes of PCI Express 3.0 to communicate to a flash-based SSD. Or flash memory on an M.2 card of some kind, and now you have 16 gigs of high bandwidth cache HBM2 on your GPU, and then you have 128 or 256 gigs of flash memory on it as well, and you start to see some of the potential use cases for this and potential advantages for it. Now, there's all kinds of other questions like whose SSD controller are they using? Are they using a third-party one? Did they build one into the cache controller? Did they build one into the GPU? If they built their own, do they have the expertise to do it? Is it going to be any better or worse than the other controllers out there? There's a lot of questions to answer there, and then on software implementations and that type of stuff too. They also changed a couple of other things or introduced a couple of other new features that I'll touch on quickly. More detail will be in the review at pcpro.com, where I spend a whole lot more words kind of discussing these topics. One is an update to the programmable geometry pipeline. This is essentially the task that has existed for a long time, where if you're in a scene that has 200 million polygons, but you only ever actually want to display 20 million of them, or you're only the viewer, the camera can only ever see 20 million of them or 2 million of them, that's an order or two of magnitude that you have to cull down. And it's a complicated, compute intense kind of task for GPUs to handle. So what AMD wants to do is to improve what they say peak throughput per clock of Vega by 2x. Compared to Polaris. And they do this with something called a primitive shader, which is essentially going to replace vertex shader and geometry shaders. Now I say that, replace them. This is basically, the idea is that the game is giving the shader knowledge about where it is in the scene ahead of time, so it can intelligently cull polygons ahead of time. It's a good idea. The problem is it requires a lot of developer interaction from the beginning, right? So this is not a DirectX feature. This is not a Vulkan feature. This is simply a Radeon API SDK type technology and feature, which could improve performance in some specific instances if game developers are willing to implement it. And it'll be interesting to see if they're able to do that. AMD does think that the primitive shader that kind of handles vertex and geometry all in one step is kind of where APIs will move going forward. So we'll have to keep an eye on that. And if that's something that like Microsoft and the Kronos group decide they want to do, maybe in DirectX 13 or something, you would actually see that being implemented. But it's good to see AMD kind of taking a proactive stance on these types of things and building these technologies for developers to take advantage of. They talked a little bit about the next generation compute engine in Vega. It's the same, actually, 128-bit single precision operations per clock, which is interesting. So now we know that the IPC of the next generation compute engines or units is the same from Polaris to Vega. We don't know how many compute engines there will be inside a GPU. What they did say is that they're able to vastly improve the efficiency of 16-bit and 8-bit operations, so half precision and then 8-bit operations, by doing packed math. And they also did mention that double precision rates will be configurable on these upcoming Vega GPUs, which is exactly what happens with NVIDIA GPUs today, right? Where the Titan X Pascal version has a significantly lower double precision throughput rate than, say, the original Titan did in comparison to the GeForce parts, right? So, or comparison to the Quadro parts, I'm sorry. So we'll see how that pans out as well. And then the final change that they've announced, or the final feature that they've announced, is the next generation Pixel engine and a feature called drawstream binning rasterizers, which is a lot of words that basically change the way rasterization can occur in the GPU, that it won't always, that it can occur into a more tile-based form. This is tile-based rasterization is really a feature that started in mobile GPUs because it's extremely power efficient, but it's not necessarily highly performant in some instances. Interestingly, this is AMD's first kind of foray into tile-based rasterization. NVIDIA started doing tile-based rasterization 2 generations ago, but kind of secretly. They never really told anybody. There was a good article by David Cantor that discussed it and showed it and like wrote a really simple application and demonstrated how you could actually tell they were doing tile-based. So that's what AMD plans on doing as well. They plan on offering tile-based drawstream binning rasterization, which is essentially tile-based, to help that they call like fetch once enabled by smart primitives, rasterization with on-chip bin caches. And it basically allows you to have proximity hits on your cache, right? So it should be more power efficient that way. They also talked a little bit about the ROPs being having access to the L2 cache, so they don't have to write to a texture before they can read from it again. They can kind of do all that in the same operation. Should actually help some VR performance, as well as deferred rendering engines, which there are a lot of. So that's kind of what we know about Vega, guys. We know a little bit about the architecture. It's pretty cool. I will say that there is more new in Vega than I thought there might be so far. And we still don't know anything about, clock speeds, processor core counts, what to expect in terms of performance, right? They're kind of purposely leaving this out. But I would expect the same kind of trickle of information for Vega that we saw with Polaris. It seemed to work out pretty well from them and from a marketing and consumer awareness standpoint. So that is what the big Vega and Vega 10 news is here from CES. Go to PCPro.com. I have the article. You can see all the slides and diagrams and read a little bit more on those new feature details and what I posit and think and theorize they might actually be useful for and what they might affect for game performance going forward. Pretty excited. Everybody's looking forward to having 250 gig GPUs, I assume, with whatever they tend to do with this new memory controller, I guess. So we'll catch you guys later, and more Vega news relatively soon, I'm pretty sure. Thanks, guys.